join. Okay. So once again, good afternoon to all of you. Sorry, I have shared a PDF file instead of I'm supposed to share with you a PPT, so you will be able to see the figure properly. Okay. So what I was telling to you, that we are studying the control equipments for the air pollutions at the source. Is it? As I have mentioned, one of the important statement with respect to control of air pollution is there is a need to control the air pollutants at the source, because it is quite difficult to control once it is emitting into the atmosphere. So that's why we are trying to understand what kind of equipments we can use to control the air pollutants at the source, specifically in the industries. Okay, so till now we have studied settling chamber, then cyclone separator, then wet scrubbers, different types of wet scrubbers we have studied, Venturi scrubber, then tray tower, spray tower, like this, cyclone scrubber, cyclone wet scrubber. So various types of scrubbers. Then we have studied one more equipment, that is a fabric filter, is it? And the last equipment we are going to study the electrostatic precipitator, which is one of the efficient equipment. Means if I want to talk about the efficiency of electrostatic precipitator, its efficiency is more than 90, it's almost it is 99.99% efficiency. Very fine particles we can control with the help of electrostatic precipitator. Okay, so I request you to start drawing this figure, and time being other students will join, and then I will explain this. Okay, so please draw this figure. Is it visible properly? Hello guys, are you drawing? I will try to search the figure in the book also. Okay, Priyanka. Over, guys. You can comment, then I can proceed. Let me know. Over. Finish within 2-3 minutes. I hope you have finished. I have taken 2 minutes break. So I'm back now. We'll continue. Okay. No message I'm observing here. That means shall I consider that you have completed? Hello? Guys, shall I consider that you have finished? Or no one is active here in the meeting? Good. I'm getting responses. Okay, good. Then we'll continue further part. So I will explain first. As I told you, this is the last equipment we are going to study about the control of equipment, control used equipment which can be used for the control of air pollutants or dust particles, we can say, not for the gaseous pollutants. Only one equipment we have studied which can be used for the control of gaseous air pollutants along with the dust particles, and that is nothing but the wet scrubbers. In that, there are different types of wet scrubbers. Okay, but all other equipments can used for the control of air pollutants, control of gaseous air pollutant. Okay, now first of all, I would like to tell you what are the parts included in this electrostatic precipitator. Electrostatic precipitator is very important one kind of equipment, and its efficiency is very high. It can help to remove very small size of the particulate matters, that we can say tenth of a micron can be removed by using this equipment. Okay. Now I would like to tell you what are the parts included in this equipment. So first one is the source of high voltage. So here in this figure, source of high voltage to power supply is provided over here. Am I right? So source of high voltage is provided, and that can be used for the providing the potential difference between two electrodes. One is the discharge electrode and another is the collecting electrode. There are two electrodes in this electrostatic precipitator. Are you able to see this? The center one wire, like there are the different types of electrostatic precipitator can be considered. So this is the tube type of electrostatic precipitator. So few more figures I will show. In that you can see the plate type of electrostatic precipitator. Okay. Then this in a tube type electrostatic precipitator, at the center you are observing a wire, and that wire is nothing but the discharge electrode, and at the bottom there is a weight is attached. Why should be attached a weight? That wire should not move here and there, otherwise there will be a short circuit. Getting? And the cover at the or the inner wall of this electrostatic precipitator is the collecting electrode. The collecting electrode is the negatively charged, and the discharge electrode is the positively charged. Okay, so remember these two things. Collecting electrode is a negatively charged and the discharge electrode is a positively charged. A high potential difference can be generated in between the collecting electrode and discharge electrode. Okay, now what else is included here? I'm not explaining principle yet. I'm just telling you what are the components are included in the electrostatic precipitator. Then the next one is the inlet and outlet for the gas. Is it? Where is the inlet? Gas flow. Inlet. Gas is flowing from this, and with a natural way, it will move in an upward direction and it will go outside through this outlet. The gas outlet and inlet for the are provided. Okay. Then the collector, disposal material collection, we can say disposal material collection. That is nothing but the upper bottom here need to be provided. It is not shown in the figure, but that also be required in the electrostatic precipitator. Okay, and we have also provided a casing out, is it? We have also provided a casing out to avoid the shock, electric shocks to the workers who are operating this. As this is a very complicated equipment, one need to be take very proper care, and or the supervised skilled supervisor is required to handle this electrostatic precipitator. So the gas will flow from this, and this electric discharged, this discharged electrode, when the gas is blowing through this channel, the discharged electrode will charge the particles in the sense particulate matters present into the gas, and because of it, that particulate matter getting charged, that particulate matter will start attracting towards the negatively charged collecting plate, collecting electrode. And once it is attracted towards the collecting electrode, then you can remove by mechanical method or by automatic method and make it to drop down at the bottom and can be removed. As I told you, the efficiency of electrostatic precipitator is 99.99%. Means even these are removing the particle size. Let me remind that particle size, 1 micron size or less than that micron size particles also can be removed with the help of electrostatic precipitator. Earlier we saw that gravity settling chamber can be used to remove the particle size whose size is greater than or equal to 50 micron. Then we have studied cyclone separator. It can be helpful to remove the particulate matter in the range of 5 micron to 10 micron. Then, sorry, it can be used to remove the particles whose size is equal to or greater than 10 micron. Then we have studied back filter, which is efficient to remove the particle size in the range of 5 micron to 10 micron. Is it? Then the next one is the electrostatic precipitator, which one is capable to remove the particles whose size is smaller than 1 micron even. But it doesn't mean that without giving a prior treatment with the help of gravity settling chamber or cyclone separator or back filter, directly you are sending that gas through to the electrostatic precipitator. You should not do it. Why should not do? Because these the efficiency of this electrostatic precipitator is to remove the fine particles. And if you are sending the larger one particles in this area, it will get blocked immediately. It will remove definitely, but it will get blocked immediately. So that's why we need to provide the primary treatment, secondary treatment, and for very fine particles, you can go to use the electrostatic precipitator, which can remove the very fine particles. Okay, now I will explain the principle, how it is happening. Okay. There are two electrodes. One is the collecting electrode and another is the discharge electrode, in which potential difference can be maintained. Okay, because these are the two electrodes. And because of that high potential difference generated, high in the sense you can say that I can say 100 kilovolts are used. Is it? So because of that, definitely there will be the ionization creates. Is it? And due to ionization, an active glow zone will generate in between the two electrodes, that is collecting plate and discharge plate, or collecting electrode and discharge electrode. A high active glow zone will create, and that active glow zone is usually known as corona, CORONA, not this corona. This is the disease. This is the phenomena where very yellow type of glow is being observed between these two electrodes because of the ionization. And why ionization has been created? ionization is generated because of the high potential difference between two electrodes, is it? And then this high potential difference will create the corona and create the glow, yellow color glow, and that glow is being identified as a corona or corona glow. Okay, you should remember this word for the MCQ type of answers. Okay, then this gas ionization is the nothing but the dissociation of gas molecules, is it? This gas ionization is nothing but the dissociation of gas molecules into free ions. And what are the gas molecules present over here? The dust particles. So these dust particles are getting charged because of the discharge electrode is a positively charged electrode, and these are getting charged, and because these are getting charged positively, they starts migrating towards the oppositely charged electrode, and that is nothing but the collecting electrode, is it? The particle once deposited on the collecting electrode, then they lose their charge, is it? The what type of particles are entering here? You can say the gas is entering, sorry, it is moving. Let me show you. Less than 1 minute is remain. I think we need to reconnect. Mm, See here, when the gas is entering here, these are getting contact with this electric charge, discharge electrode, and because of the discharge electrode, these particles present into this gas getting electrically charged, positively charged, and because these are now positive ions, these are starts attracting towards the oppositely charged electrode, and oppositely charged electrode is nothing but the collecting electrode, that is